Hi, so objective of this lesson is to understand the basic concepts of tangents and normals. So tangents and normal. Now I'm going to just quickly take some of the examples first for standard level, and in my next video I'm going to make it for the higher level. So firstly, what exactly is a tangent and normal? So now when you look at the surface, you can simply draw the tangent at any point. Like for example, here I can draw the tangent like this. I can draw the tangent here, like you can see here like this. I can draw the tangent like this to the curve. Now the question is that if I wanted to find out what's the slope or what's the equation of this tangent, So how do we do that? Or for that matter, if I define the normal, what is normal? Now normal is actually the perpendicular to the tangent at any point along the curve. So if I look at here, the normal is going to be something like this. If I look here, normal is going to be something like this. Here, normal is something like this. So actually what happened is that if you look at the simple calculus, if I can just show this animation so you can understand how at every point the tangents and like you can see the tangent and normal, they are mutually perpendicular to each other. So let's just get started with one example. So now, for example, let's say this is a polynomial. I am taking a question with the polynomial segment. Now, question is, let's say y equals to um, x squared minus 4x. Now here, when I take x squared minus 4x, the graph of x squared minus 4x is something like this. So you're not expected to sketch the graph. I'm just sketching it for your understanding. Now, if I'm asking you to calculate the equation of the tangent when x equals, let's say, 3, and I'm finding out the equation of the tangent when x is 3 here. So actually, whenever you find an equation of tangent, you first need to have the basic idea of the slope and y-intercept form, which is y equals to mx plus c, or you can remember that slope point form, y minus y1 is mx minus x1. So here m and c are the slopes and y-intercept respectively, and here y1 and x1 is the point through which the tangent passes, and m is the slope of the tangent. Now, first question arises in front of us is that what is the slope of tangent? Now, when I look at the slope of tangent, the derivative is nothing but the slope of tangent. So this, if I differentiate this, whatever the formula I'm getting is the slope formula. So if I just do dy by dx, it is 2x minus 4. Now this is a formula to calculate slope of tangent. So if I just plug in x equals to 3 here, 2 times 3 minus 4, that is 6 minus 4, that is 2. So the slope of this tangent that I've drawn here is actually 2. So slope is 2. Now to find out the equation, I require either, if I'm using this form or this form, I require one point through which the tangent passes and the slope. And slope we already got. Now just only thing is that you got to find out what's the y value of this. So input x equals to 3 in this equation, I get y is 3 squared minus 4 times 3, 9 minus 12, which is negative 3. So to find out the equation, now slope is 2 and it passes through 2 comma, it passes through 3 comma negative 3. So you can write down the equation as y minus of minus 3 is 2x minus 3. And that is nothing but y plus 3 is 2x minus 3. And so this results in y plus 3 equals to 2x minus 6 and y equals to 2x minus 9. So this is your slope intercept form. I mean, if you wanted to write on in standard form, it is 2x minus y minus 9 is 0. So this is how you find out the slope of tangent. Now, what would have been the course of action if I had to find out the slope of normal? So the normal is going to be perpendicular to this tangent. And as we know that the tangent and the normal, they're mutually perpendicular. So the slope of the normal would have been, let's say here the slope we got is, let's say, positive 2. The slope of the normal would be, let's say, so normal will be negative half. So you could do the same thing because the normal also passed to the same point. You could do y minus y1 equals to mx minus x1. And I can take the points y minus of y1, which is -3, equals to -half x minus 3. So if you cross multiply and open the bracket, you get 2y plus 6 equals to -x plus 3. So you get its equations x plus 2y mine plus 3 equals to 0. So this is how you find out the equation of the tangent or normal to a particular given curve. Let's take one more example. So in this example, what we have got is we have to find out the equation of tangent of this curve at 2, 3. So when you're finding out the slope of the tangent, first you're going to differentiate. So you got to use the chain rule here. So the derivative is actually x squared plus 5 to the power half. So the derivative will be half x squared plus 5 to the power -half times the derivative as 2x. Derivative x squared plus 5, which is 2x. So I'm assuming that your chain rule concept is clear here. So you get that x over root x squared plus 5. Now you plug in the derivative, plug in the x as 2. You get the slope is 2/3. So once you get the slope is 2/3, what we get is you can do y minus y1 is m x minus x1. So you get y minus 3 equals to 2/3 x minus x1, which is 2. So y minus 3 equals to 2/3 x minus 4/3. If you bring this 3 here, we get y equals to 2/3 x negative 4/3 plus 3, which is going to be y equals to 2/3 x, and 3 times 3 is 9. 9 minus 4 is 5/3. So this is how you get the equation of tangent. And if you had to find equation of normal as well here, you just could take the negative reciprocal of, so slope would have been -3/2, and you could have done the same thing. So y minus y1 is -3/2 x minus x1. We'll substitute the x1 and y1. So y minus 3 is -3/2 x minus 2. If you open up the bracket, you're going to get the right answer. I mean, obviously what you wanted. So this is how you find out the slope of tangent normal. I hope this video was helpful.